This is a tour of the ENIAC. Now, before we get started, there's a few things I want to point out. First, as is probably obvious, this is not video of the real ENIAC. This is instead a recording of a simulation of the ENIAC. Second, the ENIAC throughout its life existed in multiple configurations. The configuration that we are seeing here is that where it was built in the University of Pennsylvania before it was moved to the Aberdeen Ballistics Research Laboratory. The third thing that I'll point out is that the movement of the lights that you see in this are showing the simulation as the ENIAC is running a demonstration of the Turing completeness of the machine. So let's get into looking at the different parts of the machine. Now, the most noticeable thing that you see when you first walk in and see the machine are these large panels here in the middle of the room with lots of switches on them. These are known as the portable function tables. The purpose of these is to store information that might be difficult to calculate, or perhaps measurements that have to have been made before the problem can be run. We'll get to a little bit more about what they're used for later. Now, the other thing that you will notice kind of in here in the middle of the room are these two items right here, which are the card punch and reader. The one in the back is the reader, and the one closer to us is the card punch. As you can see, the current state of the simulation does not have any real texture on them to show you what they would look like photographically. So now we're going to begin by starting at the left side of the machine and kind of work our way around talking about what each of the different components does. Now, the first part that we're going to look at here is this first unit to the left, which is known as the initiating unit. This is the part of the machine that controls the power-up sequence. It also handles the synchronization with the card punch and reader, and it allows the user to initiate the running of a program. That's why it's called the initiating unit. Now, next to it is what's called the cycling unit. The cycling unit provides essentially a master clock for the entire machine. So everything that's done, all of the calculations, are timed according to pulses that are sent out by this master clock. It generates pulses at a rate of 100,000 pulses per second, and each group of 20 pulses is known as an addition time. So those occur 5,000 times a second. One of the pulses that's particularly important in the whole operation of the machine is known as the central programming pulse. The central programming pulse is what carries in effect a command to tell something in the machine to operate, to take place and carry out some operation. Now, the next bit that we're going to look at are the two panels that are next to the cycling unit. These two panels together form what is known as the master programmer. You can see lots of switches on these panels. These panels allow you to, in effect, control repetition of a sequence of operations. It can also handle the conditional operation. That is, I can choose one of two courses of action based on whether a calculation was positive or negative, for example. This part of the machine is what really sets it apart from previous machines. This is the part that allows the machine to be able to make logical decisions and change its course of action accordingly. Now, next to that are two more panels, and they are interfaced to the portable function table. The two panels that we see here in the middle now are the electronics that connect to all of those switches on the portable function table. And it's through this that the programmer is able to, say, for example, decide that I need entry number 12 out of the function table, and I need that number to be used in some calculation. And so this controls the sequence of operations necessary to fetch that data out of the large panel of switches and feed that number into the rest of the machine. Now, before we go on, I'm going to walk around this portable function table here so that we are not walking through it. In simulation you can walk through things, but you can't in real life. So the next two units that we see here, which are roughly centered on the screen, are the first two out of 20 accumulators. The accumulators are the part of the machine where the bulk of the arithmetic is taking place. Pretty much everything is done by way of these accumulators. These are also the only places where you can store numbers that can be changed. In conventional programming, it's like where the variables would be. Now, the way an accumulator works is you can tell it to either receive a number or send a number. Now, if you're receiving a number, it's always added to the number that's already stored there. So if I have the number 5 stored there and I receive the number 7, then the accumulator will show 12. When I'm sending a number, I have two choices. I can send the number as is, or I can send what's called the complement of the number, in effect the negative of the number. And so by sending the number itself to another accumulator, we perform addition. By sending the negative of this number to another accumulator, we perform subtraction. Now the next unit over, to the right of accumulator number 2, is called the divider square rooter. It does not do all of the division and square roots itself. Its role really is to control some of the accumulators nearby, and they carry out the various subtractions very much like we do in long division in order to carry out a division or a square root operation. Now the rest of this left-hand wall is another 7 accumulators, accumulators 3 through 9. These are some associated with the divider square rooter for doing its operations. In general, if they're not being used for the divider and square rooter, they can be used for any purpose that the programmer wants. And similarly, the last one on the end is associated with what we're about to see as the multiplier. And if we go around the corner, we also see accumulator 10, which is also associated with multiplier. These hold the two numbers that are going to get multiplied together. Now, the multiplier itself are these 3 panels to the right of accumulator 10. Much like the divider square rooter, they do not do the bulk of the work in the multiplication itself. In effect, these have our classic multiplication tables in them. And so the idea is that it's able to produce multiples of what's in accumulator 10, and a particular value of a digit in accumulator 9 tells us which multiple we want. And then they all get added up, very much like we do in conventional multiplication. The adding up of all the different parts takes place in the accumulators to the right of the multiplier, these 11 through 14. Depending on how we're using it, we might only use 11 and 13, or we might use all 4 of them. In this particular simulation, we're not actually using the multiplier, so these accumulators are being used for other purposes. Now, if we kind of scoot around the back of this other portable function table, we see over here accumulators 15 through 18. Nothing particularly special about those in terms of them being associated with any particular thing, except that most of those are also able to be connected to the card punch for generating output. Right behind the corner of this portable function table, we see another one of the panels of the electronics of the function tables. I'm going to squeeze in between these two function tables momentarily here and take a look at the other parts that we've got in there. We have more of the panels that do the electronics interfacing to the portable function tables. And then we have our last two accumulators, accumulators 19 and 20. So now let's go back around this portable function table and take a look at the last parts of the machine. And over here we see the last 6 panels, which collectively are the interfaces to the card punch and reader. The 3 we see on the left are connected to the card punch immediately in front of us. The 3 on the right are connected, the 3 on the left are connected to the card reader immediately in front of us, and the 3 on the right are connected to the card punch to the right. Collectively, the group that operates the card reader is known as the constant transmitter. It can read in a card and then transmit the numbers off of that card into the rest of the machine for calculation. The last 3 that are connected to the punch are known as the printer, and they are connected to certain accumulators, and you can send a signal that says, now take the values of those accumulators and punch them out onto a punch card. All of the input and output of the machine was done through those punch cards. Now, you may think, well, can I see a printout of this? In the operation where it was operating in the Ballistics Research Lab in Aberdeen, they had a room next door that had a full suite of typical card punch equipment. So if you wanted a printout of what you were doing, you would take the cards off of the punch, walk around to the room next door, and then run them through a card reader that was connected to a printer, and you get a printout of your output. So this kind of ends our initial look at the ENIAC as a whole. The machine existed in this form, as I said, at the University of Pennsylvania while it was being constructed, and then was dismantled, moved to Aberdeen, Maryland, and reconstructed in a different configuration, and that's where it spent most of its operating life until it was retired in 1955. I hope you've enjoyed this tour. Thank you and take care.